Hello and welcome to the most recent short interview for the IATiP community. So today I'm joined with Ahmed Jafarzadeh
Yeah, that's true.
at the Tyndall National Institute. So Ahmed, could you please give a little background about yourself?
Yeah. So my name is Ahmed Jafarzadeh, as you said. So I'm working in Tyndall National Institute. I'm a graduate master's student, and I'm working in electronics area. And I had a chance to be part of the IMPAQT project in Ireland, and I'm working and I'm developing a sensor under supervision of Dr. Brandon O'Flynn in Tyndall National Institute. Okay.
Okay, so could you tell me a little bit about what you're doing?
Yeah. So the thing that we are doing is it's basically a substitution for wires underwater. So what we are doing is building a sensor network that they can communicate wirelessly underwater. So as you probably know, the electromagnetic signals cannot propagate underwater because they get attenuated very easily by the chemical properties of the water. So what we are building is we are using ultrasonic signals to transmit the information wirelessly to another location. So as I told you, it's a basic idea, but it has a lot of challenges that we are trying to solve, and it will enable a lot of researchers in future to use this communication platform to probably building sensors or probably monitoring the fish health, the water quality, all of them in real time. That's the base. That's the most important thing in our product. So there are a lot of product at the moment in the market that you can, for example, install a sensor underwater and then let it to connect to collect some information, and then come back after a couple of weeks and then collect it and then take the data out of it. It's called archival sensors. But the problem is that whatever happened in that period of deployment, you are not aware of it. So you will find out about the problem or anything that happened after you retrieve the sensor and read the data. So we are replacing that archival tag with real-time communication. So basically, the farmer would have the chance to see the data in real time and take the decision at the right moment, not at the moment that it was already late for taking a decision. So that's the basic idea about what we are doing here.
Great. So can it work for any sensor? I guess that's the intent.
Yeah. So we are having different approaches to this. So we are basically focusing on bringing the platform. So we're gonna give the researcher a very small module, like a miniaturized module, that they can connect to their sensors, and then it can read the data from the sensors and transmit it to, we call it a gateway buoy, and that gateway buoy send this data out using a complex linking and stuff, and finally it send it to the cloud so the farmer can see the sensor data on the cloud. So it would really be easy for the farmers to watch it on a laptop without going to the site. So I can't tell you that it will work on every sensor, but we are trying to develop a platform that can be easily integrated using different methods. For example, we have optical links, we have wire links that they can use to connect our transmitter node to their sensors.
Wow, that sounds very impressive. So what stage of development are you at?
Yeah, so at the moment, we developed the prototype version. It's working. We are working closely with Mind Institute, and we are deploying one of the product, because we have a couple of products for different uses. But one of the products that we are working now is finished, and we are, as I told you, we are working with Mind Institute to deploy it in west of Ireland. So they're gonna deploy it in some IMTA sites to monitor the seaweed movement in water, and also the seaweed, the amount of sunlight that the seaweed can receive. So this will be the first deployment. It will happen before the end of the year, so I would say in a couple of weeks. And we are also working on the communication platform with a university in Italy, the University of Rome. And we are integrating a sensor that they had. It's called optical electronic tongue. We are adding our technology to their platform, so they will be able to transmit their sensor information, which help the farmers to find out about the diseases in water. So as I told you, we are in the prototyping stage now, and we are looking really at the moment, we are looking for the partners, for the researchers who are interested in our product or interested in usage of our product to be connected, like to make a connection with us, and we will be happy to cooperate with them and be a partner with them to enable more sensors to be used underwater.
Okay, so within the IMPAQT project,
yeah,
at what stage do you hope to be by the end? Does it end at the end of 2021? Is that right?
Yeah, the IMPAQT project will end in 2021, and we are hoping at that stage we can add the functionality of real-time monitoring to the sensor that we are building. So we are, as far as I know, we are building nitrate and phosphate sensors as a part of IMPAQT project, and also the new one, the optical electronic tongue, they call it. So we are hoping that at the end of IMPAQT project, we're gonna have these sensors that can communicate in real time using our system, and we are hoping that it would give a better insight for farmers about their aquaculture sites.
Great. Okay, so at this stage, you're looking for collaborators.
Yes.
To
exactly.
do more trials. And
yeah, if I had the chance, I would go and talk with each individual researcher to like ask them what you need. For example, we are working closely with BIM. Mm-hmm. And we are talking with them. We are asking them what they need. What's, for example, what are the pain points in the farming industry? Because I'm an electronics student and engineer, so I really don't know what is happening and what are the pain points in industry. But fortunately, thanks to a conference that happened 2 months ago called Hatch, we made a lot of links with BIM, with a lot of farmers. That they are really eager to use our system in their farms, and we are asking them, like continuously, we are in touch with them to ask them what they need. For example, like we had a meeting 2 weeks ago about the problems for fish feeding. So mm-hmm. They were asking us if we can build or if we can integrate our sensor, our transmitter node to a sensor that enable the farmers to know when the feeding is enough, in simple terms. So for example, that is one thing. So I would like invite everybody, like anybody who is working in this area, to like contact us. Maybe we can form a cooperation, and we can get something really useful out of the current technologies.
Great. Do you know of anybody else who's trying to do this sort of thing?
We know that there are teams in like they are making commercial products. But as far as we know, they are doing in an archival mode, so they are not using real-time communication. Yeah, okay. There are a lot of, like, I know, like a name of companies, for example, WSense in Italy. They are making it the same kind of with the same idea, but they are using a cable-connected system, or some of them are using like big acoustic transducers, for example, for robots, for big underwater drones. So the main difference of our research project comparing to them is that we are making small, like miniaturized version of the communication platform, and that's the main advantage of our project.
Fantastic. And so, is the aim to commercialize this product at the end?
I don't know exactly, but yeah, for sure, if it would be useful, why not? So at the moment, we are not looking for any like funding or any, because we are already funded under IMPAQT project. But we are looking for enabling farmers to solve the problems really, because like Tyndall National Institute is a governmental institute. So we are already funded by the government, so we are not worried about the money. So we are focusing on solving the real problems. So as part of that, like as I told you, we are all the time like communicating with farmers to know what's the problem. So yeah, but I would say if it can solve a problem, yeah, why not? So we will go for commercialization at the end.
That's excellent. Okay. So I guess you've already explained what next. So how would people find out more if they're, firstly, if they'd like to know more about what you're doing, but also how to get in touch with you?
Yeah. So there is a website for IMPAQT project, impactproject.eu, that they can visit, and there is a contact for each of us there. And they can specifically contact Brandon, hopefully my supervisor. He is the direct connection of me to the IMPAQT project. So we can get involved and we can share our ideas regarding the project or the challenges that they are facing and they want to solve.
That's great. Well, it's very exciting, and I can already think of several people who will be very willing to talk to you about it. So thank you very much for your time.
You're welcome, Georgia. It was really nice to talk to you.
And you. Thank you very much. I appreciate it.
Thank you.